Hello students, my name is Birbal Sharma. Today is the fourth part of series of important questions of IOQJS. It is from physics, but the second part from electricity. Now the questions. It is the first question. Two bulbs of specification 50 watt, 220 volt and 100 watt to 200 volt. Okay, here must be 200 volt. Rating is same. Are connected first in parallel and then second in series 220 volt. Power supply. Choose the correct option. It is the question from IJSO stage 1 2013. Think about it. The resistance of the valve will never change. It may change slightly with the temperature. It is calculated by graved voltage. Graved voltage means this voltage. This voltage 220, also that is 100 watt, 200 volt, 200 volt. So we can say that what is the resistance? P is equals to V square upon P. V square upon P, that is V square upon R. We can calculate R. R will be equals to V square upon P. Think about it. Resistance, higher is the power, lower will be the resistance. So we can say R50 is greater than R100. Definitely, because all the appliances they are made up for parallel use. All the appliances. सिर्फ एक चीज को छोड़ के जो दीपावली पर सीरीज होती है ना उसको छोड़ के बाकी ऑल द अप्लायंसेस दे आर मेड अप फॉर पैरेलल यूज. ये ग्रेव्ड वोल्टेज इस पर ही हम कैलकुलेट करते हैं द रेजिस्टेंस, और ये रेजिस्टेंस कभी चेंज नहीं होता है. किसी वोल्टेज पे आप यूज कीजिए. विद द हेल्प ऑफ दिस फॉर्मूला वी कैन टेक द आइडिया दैट इज R50 रेजिस्टेंस ऑफ 50 watt valve will be more than the resistance of 100 watt valve. अब think about the question. Two bulbs 50 watt 200 volt and at 100 watt 200 volt. Power of 50 is this one, greater 100 watt. Now think they are connected, first connected in parallel. So in parallel, what is P? V is constant, V square upon R. We can say higher is the R, higher will be the power. R जितना greater होगा power उतना ही greater होगी. Oh sorry, उतनी ही less. R जितना greater होगा, पर R is greater for 50 watt, R is less for 100 watt. So P will be greater for 100 watt, means 100 watt will glow more. In first case 100 watt will glow more in comparison to the 50 watt. Now think about that. It's the first case. In second case देखिए, they are connected in series, but in series I is constant, so we will use P is equals to I square and R. All the appliances they are made up for parallel use. हमें इस वोल्टेज पे यूज करना चाहिए. अब इस वोल्टेज पे यूज नहीं कर रहे हैं तो जो पावर लिखा है 50 वाट एंड 100 वाट देयर इज नो मीनिंग. ये अलग पावर शो करेगा. तो करंट डेफिनेटली करंट विल बी सेम, आर विल नॉट चेंज. ये शो कर रहा है हायर इज द पावर, हायर इज द रेजिस्टेंस और हायर विल बी द पावर. पावर इसका ग्रेटर हो जाएगा और रेजिस्टेंस हमें मालूम है R50 ग्रेटर है. R बिकॉज ऑफ R50 इज ग्रेटर देन R100. So 50 watt will glow more in series. अगर ऐसे लर्न नहीं कर सकते हैं तो एक कीजिए, पैरेलल में ज्यादा वाट का है वो ज्यादा ग्लो करेगा, सीरीज में जो कम वाट का है वो ज्यादा ग्लो करेगा, बिकॉज I is constant, P is directly proportional to R. So now think about the options. 50 watt will, first case 50 watt glow brighter, no. Second case 50 watt will glow greater, ये भी possible नहीं है. In C, in first case 100 watt will glow brighter and 50 watt, second case 50 watt will, so answer must be C. Correct option is C. Okay, now the next question. This is the next question. The circuit shown in adjacent figure consists of two external resistances of 10 N external resistance of 10 ohm connected across two batteries of EMF 6 volt and 9 volt with internal resistances 1 ohm each. Okay, find the power dissipated by the, we have to find the power in this case. अगर हमें इसका करंट मालूम हो या फिर वोल्टेज मालूम हो across this one, but across this one 9 volt 1 ohm, 6 volt 1 ohm, they are connected in parallel. So we can say in this way, that is in parallel it is E1, it is R1 plus and minus, it is E2 and R2, they are connected in parallel. Then we can say the resistance here is given, that is R is equal to 10 ohm. We have to find the current here I. So we will change it, we will convert it into a battery, that is E equivalent and R equivalent. E equivalent and R equivalent, external resistance is same, that is 10 ohm. We have to find the current I. How we will find? How we will find the equivalent E? So E equivalent in parallel is given by E1 R2 plus E2 R1 divided by R1 plus R2. So E1 is in question given 9 volt, R1 is 1 ohm, E2 is 6 volt, R2 is 1, that is E equivalent will be 9 into 1 plus 6 into 1 divided by 1 plus 1, that is E equivalent will be 15 by 2, that is 7.5 volt. 7.5 volt. Now what is the R equivalent? R1 and R2 connected in parallel, so it will be equal to 1 by 2, that is 0.5 ohm. We have to find the current I. How we will find current I? So in this figure I will be equal to E equivalent 7.5 divided by R 10 plus 0.5, that is 7.5 divided by 10.5, or we can also write this cancel 75 by 105. 15 से कैंसिल करूँ 5 टाइम और 15 से कैंसिल करूँगा, that is 7 टाइम, that is 5 by 7. It is the current. We have to find the power in 10 ohm. So how we will find? We know, okay, we know current is I, resistance is 10 ohm. Then how we will find? First of all, check it, this calculation is correct or not. 15 5 is 75 or 7, 5 by 7, okay, ampere. Now the power dissipated in 10 ohm, that is equal to I square into 10. I square means 25 by 49 into 10, that is 250 by 49. We can calculate it. If it is 50, then it must be 6. Now the less than 6, that is 5.1, 5.1 ohm. Okay. 5, if it is 50, then it is 5, but it is 250 by 49 means somewhat greater than 5, that is 5.1. So it is the answer, 5.1. Power is what? Power is what? This will be the power dissipated, so it is given 5.1 watt. This was the question number 2. अब देखिए question number 3. 3 question is this one. Okay, the effective resistance between A and D in the circuit shown in the adjacent figure. A and D, current यहाँ से enter करेगा, means current इधर निकल रहा है. It means a battery is connected between A and D. You have to find the equivalent resistance. Then no current will through this one and this one. Our circuit, if we redraw the circuit, it is 5 ohm, this point is A, it is 10 ohm, it is also 10 ohm, it is 10 ohm, it is also 10 ohm, it is 5 ohm, and this point is D, 5 ohm, this point is D. Now think about these two resistors, they are connected in series, that is 10 plus 10, 20, they are also connected in series, same current will flow through here, okay. So 10 and 10 connected in series, 10 and 10 connected in series, so this means 20 and 20 they are connected in parallel, so this will be 5 ohm and 20, 20 that is 10 ohm, it is again 5 ohm, this is A, this is D, so R equivalent all are connected in, AD will be equal to 5 plus 10 plus 5, that is 20 ohm, this is the answer. So answer is D, 20 ohm, correct option. Now for this 5 ohm or that 5 ohm circuit not complete, so they will be in not in circuit between A and D. Okay, the next question, that is number fourth question is this one. It is 2016 IJSO, okay, rod AB of radius 2r, इसका radius है that is 2r, इसका radius r, इसका length l, same, its length same is given in the question. They are of joint series, they are same material, it means row same length, the combination carries a current I or current is flowing same. So choose the correct option, correct statements. VAB is equals to 4 times BC, VBC. Current per unit area, now think about this option, current per unit area, current through this wire or this wire is same, but area of this one will be more in comparison to area of this one. So current per unit area will not be equal, so this option is wrong. Now think about the resistance of AB is greater than that of BC. This wire is thick, length is same, material is same, this is thick, so its resistance will be less. Resistance will be less in compared to the resistance of BC. So ye also wrong. Now we have to find the resistance of this one and this one. So resistance RA, resistance of AB, okay, R of AB, that is equal to, formula is rho, material is same, L upon pi into 2R square, that is we can write rho L divided by 4 pi R square, the resistance of wire AB. Now the resistance of BC, its area is R, length is same, so RBC will be rho same, L same, pi into R square. Now think about RAB and REC, which one is greater? Resistance of BC is greater, it is how much time? 1 by 4, 4 times greater. So the C option is wrong. Now think about this option A and D, VAB is equal to 4 times VBC. So it is clear this RAB resistance and RBC they are connected in series. So in series V is equal to IR, it is constant. So V is proportional to R, means V1 upon V2, that equals to R1 by R2. We can also write VAB divided by VBC is equals to RAB divided by RBC, or from here we can find the value of RAB upon RBC, that will be 1 upon 4 from here, this one and this one. RAB divided by RBC, that will be RAB 1 by 4 times. So we can write VAB cross multiply करें, VBC is greater than, greater or we can say 4 times, we can say 4 times VBC is equals to 4 times VAB. So now think about option first A and B, 4 times BC, it is wrong. So correct option is VBC is 4 times VAB. So correct option is D. Is the question number 5th. that is, refer the adjacent figure, the voltmeter reads 117 volt, its V is equals to 117. Now remember it, V and R, they are connected in parallel, so potential difference across R will also be V is equals to 117 volt because they are connected in parallel. Now the ammeter reads point current from here, it is I, 0.13 ampere. We can write total current from enters from here, I will be same, I is 0.13 ampere. Now the resistance of voltmeter ammeter 9 kilo ohm this one, इसका resistance है R is equals to 9 into 10 raised to the power 3 ohm. It's the resistance of voltmeter. Now resistance of ammeter also given, its resistance is R dash 0.015 ohm. Now think about this one. We can find the current through voltmeter from here. We can easily find, suppose it is I1, then what is the value of I1? Apply Ohm's law across this, only Ohm's law across it. What is the value of I? I1 will be equal to V upon R. V means 117 divided by 9 into 10 raised to the power 3, or we can write 13 into 10 raised to the power minus 3, we can write 0.013 ampere. Current is 0.013. Now think about this one, this current is suppose I2, we can say I is equals to I1 plus, it is I2, we have to find the current I2, so I2 will be equals to I minus I1, I is 0.13 and it is 0.013, that is if we subtract this one, then there will be 0.117 ampere. 0.117 ampere. Okay, it is 117. Okay, it is current through resistance this one. Or we know, think about it. Now think about this one. Here apply Ohm's law across it, across R. So across R by Ohm's law. Ohm's law. We can find I2, we know very well. We have R will be equals to V upon I, V upon I2. V is 117 divided by 0.117, that is equal to 1000 ohm, means R is equals to 1 kilo ohm. It is the resistance. It is of the year of 2018, 1 kilo ohm. So correct option is B. Now the next question, question number 6th. It is the 6th question, a very easy question. In the given circuit, the equivalent resistance between point A and B. Now think about it. Why current flows through the circuit? Due to the potential difference. Due to the potential difference. Now think about it. A battery is connected here. Current यहाँ से I enter. At this point is O. No current will flow in this one because start current O से start होगा और फिर O पर ही वापस same potential पर current flow नहीं होगा. There will be no current from here. कह सकता हूँ no current in this triangle. It means our circuit is only this one. This point is A, current is I. This point is B, current is I. It is 2R. It is also 2R. So what are these two are connected in series. So R AB is equals to होगा 2R plus 2R. That is how much? 4R. It is the answer. It is the answer. Correct answer is B. It was the question number 6. Next question number 7th. 7th question is this one. Reading of ammeter in ampere for the following circuit is, we have to find the current through this line. There may be 2 or 3 methods, but the simplest method is think about this line AXY. AXY and so AXB and AXB and AYB are in parallel. It means across this line and this line potential must be 2 volt. We can write this one. It is 1 ohm. Here is ammeter. It is 1 ohm. It is also 1 ohm. It is ammeter. It is 1.5 ohm. It is 1 ohm. The battery is connected here. That is 2 volt plus minus 2 volt. It means this line and this line they are in parallel. It means, okay, two resistances. It is 1 point. Think about this line. Suppose this point is A or this point is B. It is okay AB. So potential. Think about only this line AB. 1 ohm. It is 1 ohm. We have to find the current here. Potential across is V is equals to 2 volt. So what is the equivalent resistance of this line? That is 2 ohm. R equivalent is 2 ohm and V is 2 volt. We have to find the current here. I will be equals to V upon R, that is 2 by 2. That is how much? 1 ampere. 1 ampere current will flow through this ammeter. Here will be this current 1 ampere. So we have to find the reading of ammeter. It will be 1 ampere. Question number 7. Next, question number 8. The question number 8. The net resistance between the points P and Q in the circuit diagram is this one. Okay. We have to find the current resistance between P and Q. It means a battery is connected between P and Q. मैं ऐसा कनेक्ट कर सकता हूँ. It's the battery. करंट यहाँ से फ्लो होगा प्लस माइनस. वी हैव टू फाइंड द रेजिस्टेंस बिटवीन P and Q. This is earth. We can say its potential is 0 volt. It's also 0 volt. If we suppose this point is A, this will also be A. How many points are there? P, Q and A. 3 points. But we have to find the resistance between P and Q. Then write P and Q at extreme distance. And other points between P and Q anywhere. So other point is A. This point is A. Think about this point A. Why this is A? Because its potential 0. Earth, its potential also 0. So both will be same point. Now think about this resistance between P and A. It is R. Now think about this resistance between O and P, Q and A. It is Q, Q and A. Now these two resistances are connected between P and Q. So it is P, it is Q, it is R, it is also R. A battery is connected here. जो मैंने connect किया था. Current यहाँ से flow होगा. You can think about this easily. These two are connected in parallel. So equivalent resistance will be equals to 2R and it is R by 2. This point is P, this point is Q. It is P, it is Q. So what is RPQ? Both are connected in parallel. So will be 2R into R by 2 divided by 2R plus R by 2. That is 2 से 2 cancel. It is R into R divided by 5R by 2. 5R by 2. R cancel. So RPQ is 2R by, that is 5. 2R by 5. So correct option is B. Okay. Now the next question, that is 9. Ninth question is this one. If two bulbs whose resistance are in the ratio of 1:2 are connected in series, again think about it, in series. So in series, what will be constant? I will be constant. In series, the power dissipated is them in the ratio of this one. We know that P is equals to I square and R. इज इट क्लियर? हम V स्क्वायर अपॉन R भी यूज कर सकते थे, बट एट दैट टाइम वी हैव टू कैलकुलेट द पोटेंशियल डिफरेंस अक्रॉस ईच बल्ब. तो इट इज इजी, I कांस्टेंट मुझे कैलकुलेट करना ही नहीं है, तो I इज कांस्टेंट, so we can write P is proportional to R, means P1 upon P2 that will be equal to R1 by R2. वही फाइंड करना है मुझे. The resistance 1:2, R1 R2 is 1:2. It means P1 upon P2 is 1 upon 1:2. The answer 1:2. Correct option is B. Now the next question, that is 10th. The 10th question. Okay, in the circuit shown below, all the resistances are equal, each equal to R. The equivalent resistance between A and C. A and C करंट यहाँ से एंटर करेगा, इधर निकल रहा है. Okay, now we will think about it separately. Think about this line. It is known as the symmetry line. अब मिरर, अगर हम यहाँ प्लेन मिरर रखें, then this will be the image of this one. So this line is known as symmetry line, or we can say this right side will be the image of this left side, this symmetry line. Symmetry line will never be taken along the line along which we have to find the resistance. Symmetry तो इधर भी होगी, लेकिन ये काउंट नहीं करेंगे. अगर ये काउंट करेंगे तो जीरो रेजिस्टेंस हो जाएगा. तो याद रखिए, सिमेट्री लाइन से क्वेश्चन सॉल्व करते समय सिमेट्री लाइन कभी भी उस लाइन के अलोंग नहीं लेंगे जिस लाइन पे, जिस पॉइंट के बीच मुझे रेजिस्टेंस फाइंड करना है, और अदर किसी के बीच ले सकते हैं. हम ऐसे भी ले सकते थे, थोड़ी टिपिकल हो जाएगा. सिंपलेस्ट ये, इट इज सिमेट्री लाइन मींस ईच पॉइंट ऑन सिमेट्री लाइन, सिमेट्री लाइन will be at same potential. E will be at same potential means point this one and this one will be at same potential. It means no current will flow from B to D. It means we can remove it, remove कर सकते हैं. नेक्स्ट देखिए, अगर हम री ड्रॉ करें सर्किट, that will be 1 ohm, it is R, it is also R, it is R, or this will be R, it will be R. Current enters from A point and leave it at B point. It is R, R, ABR, ABR, R and R. Same current will flow through this line and this line. It is 2R. They are connected in series. These two resistance, they are also connected in series. They are also connected in series. So we can redraw it towards here. देखिए, it is 2R, 2R and 2R. This point is A. This point is D. D. Okay, C, not D. It is C. C point. We have to find the calculate the resistance between the A and C. This C point is also C point. It is 2R, it is 2R, it is 2R. So all are connected in parallel. So RAC will be equals to 2R by 3. It must be the answer, but there is no option, that is R equivalent resistance between A and C is 2R by 3. So correct option is none of these. Our answer must be 2R by 3 because 2R, 2R, 2R connected in parallel. So equivalent resistance in parallel will be 2R by 3. This was the question number 10. Now the question number 11. Now it is subjective question, most important question. Think about it. A milliammeter of range 5 milliampere. It is written 5 milliampere. Its resistance is 0.5 ohm. Joined in the circuit as shown in the figure. Find the value of current for which the meter gives the full scale deflection. Full scale deflection means this one. Suppose this current is I1 is this one. When A and B are as terminals. Now think about first part A. A and B are terminals. So we can rewrite, it is ammeter, it is 0.5 ohm, its resistance 0.5 ohm, it is 0.5 ohm, okay. Its range is, range means from current is, that is 5 milliampere. Now think about this point is A, okay, it is 0.1 ohm, rest we can connect here. How much resistance? 2 and 0.2 and 0.3 ohm. This point is B. We have to calculate this current I is to be find. Suppose here current is I2. So I will be equals to this I1 plus I2. We have to calculate I2. I2, we know this line and this line in parallel. So we can say I1 into this total resistance. So I1 means 5 into this total resistance 0.5 plus 0.5, that is 1, is equals to this current I2 into this resistance, this line resistance is 0.1. So what is the value of I1? 50 milliampere. What we have to, it is I2, what we have to find the current total I, it is I. So I will be equals to I1 plus I2. I1 already given, 5 plus 50, that is how much? 55 milliampere. That is the answer of A part. Now the second part is A and C are terminals. So this resistance will be connected with this series. Now think about it. Question is, this ammeter, this current is 5 milliampere, its resistance is 0.5 ohm, this point is A, it is 0.1 ohm, it is 0.2 ohm, this point is C. Now 0.3 connected here, 0.3 ohm. Now think about current I to be find. Here is I1, it is I2. These line and this line, they are in parallel. It means potential difference across the upper line and the potential difference across this line must be equal. Potential difference means current into total resistance. So we can write 5 into 0.8. 5 into 0.8. Again I2 into this resistance is 0.3. So what is the value of I2? 4 by 0.3, that is how much? 40 by 3 milliampere. It is I2. But we have to find the current I, because of I is equals to that is 5 I1 plus I2, 5 plus 40 by 3, that is 55 by 3 milliampere. That is the answer of second part. Now the third part is D. Think about third part, C part. This is the ammeter. Here is current I1 is equal to 5 milliampere and its resistance 0.5 ohm. This point is A, its resistance is 0.1, its resistance is 0.2 ohm, its resistance is 0.3 ohm. This point is D. Between terminals are A and last point D. So now think about this, current is I2, again we have find I is equals to I1 plus I2, I1 is given 5 milliampere, I2 is to be find. So the product of current into its resistance of this line, again the current or resistance of this line, because they are in parallel, potential difference. So we can write 5 into 0.5, that will be equals to I2 into 0.3, 0.2, 0.1, 0.6. So what is the value of I2? I2 is equals to 2.5 divided by 0.6, or we can write 25 by 6 milliampere. I total current I will be equal to I1 plus I2, that is 5 plus 25 by 6. Is it clear? 0.6, okay. So it will be equals to 30, that is 50 by 55 by 6 milliampere. That is the last answer of this question. Now the next question is, the question number 12. थोड़ा lengthy है question. It has A, B, C, D, E, F, G parts. Now read the question. In the given electric circuit, find the current in the circuit. In the circuit, current is I. Here is I. Its resistance is R. तो resistance R को यहाँ note करते हैं हम. It is R. Is it clear? Okay. First part A. What is the current? This small r and capital R, they are connected in series. So I will be equals to E upon total resistance R plus R. It's the current. Simple answer. I will be equals to this. Now think about the second part. Power output, B part. You have to find the power output. This part is clear. Second part. Power output means power across R. We know current is given, resistance is given. So power output means power in, power consumed by R, capital R. So that is power output will be equals to I square R. I square R. R is already calculated in A part, that is E square upon R plus R whole square into R. It is the power output. The second part, B part. Now relation between R and R, so that the electric power output, that means power given to R is maximum. It is an important part. It may depends on differentiation, important part, but other than differentiation we can also remember it. Now the power is E square upon R plus R whole square. Now think about it. C part. For maximum power, dP upon dr must be 0. dP upon dr must be 0. P already calculated, d upon dr, that is E square upon R plus R whole square into R. It must be 0. We can easily differentiate it. These are the two steps. First step is this one, and second is R. We can differentiate it. Now solve it. It is d upon dr means E square upon R plus R whole square as such into dr upon dr plus R as such d upon dr of E square upon R plus R whole square. It must be 0. We have to calculate it. So then E square upon R plus R whole square, the value of dr upon dr is 1, और इसको differentiate करेंगे minus 2 times ER into R divided by R plus R to the power 3, that must be 0. We can easily find from on calculating small r must be equals to capital R. You have to remember, if internal resistance, total internal resistance and external resistance are equal, then current will be maximum, so power will be maximum. Remember, if total internal resistance is equals to external resistance, then I will be maximum, so power will be maximum. So this is the relation between external resistance and internal resistance. Now the next part, it is C part. Now D part, value of output, value of maximum output power. Now the D part of the question, D part, we have to find the maximum power. We know that small r is equals to capital R, and power maximum is E square upon R plus R whole square into small r. We can calculate that is E square by 4R. It is the maximum power. It is the answer of part D. Now the next part is E. E part is E part is plot graph between power and resistance of load. Power of resistance and load, P and R. That is E part, like graph between P and R. We know that is what P is equals to E square upon R plus R whole square into capital R. We have to plot the graph between P and R. It is R, load, it is power. Think about it, if R is equals to 0, then what is the value of P? Will be 0, this point. Now think about R is equals to small r. If we put here, then what is the value of P? That will be maximum E square upon 4R. At this point, small r is equals to capital R, it will be E square upon, that is 4R. Now if R is equals to infinity, capital R is equals to infinity, then what is the value of P? Will be 0. P will be 0 means at the graph will be in this way. Now think about this graph, it is curved, it starts from origin, it will be infinity when R becomes infinity. Now for next part, EF, it is given that, think about it, if we take any value of P, any value of P, there will be, it is P, there will be two values of R, it is R1 and R2. In next part F, we have to find the relation between R1, R2 and small r, that is internal resistance. So how we will find this one, that is relation between R1 and R2 and small r. So for R part, where P will be equals to E square upon R plus R whole square into R. On cross multiplying, we can write it P into R plus R whole square, that will be equals to E square into R, that is P into R square plus 2RR plus R square, that will be E square into R. Next R square plus 2RR plus R square, that will be E square upon P into R. Now transfer it towards here, R square plus, that is R into 2R minus E square by P into R plus R square, that will be 0. It is the quadratic in R. It means R has two values. Suppose R1 and R2. You know that alpha and beta are the two values of R, then alpha into beta and alpha plus beta, it is given by same thing. So R1 into R2 is equals to C by A. C by A means the factor which is free from capital R and the factor that is R square. C by A means R1 R2, that will equal to R square upon 1, or we can say R is square root of R1 and R2, or means we can say this is the answer of part F. This is the part F. Now next, the last part E, F, ask what is the efficiency of the cell when it is used for supplying maximum power? It is the most important part, last part. That is G part. G part, you have to find the efficiency. For efficiency, eta is power output upon power input, but it is for maximum power. Maximum power, we have already calculated power output. Power output we have already calculated is E square upon 4R. Now think power input. Power input means power given by the battery. Power given by the battery, that is Pi is equals to, now think about the battery, this one, it is the battery plus minus E, it is R, it is capital R, it is I, but for maximum power small r and capital R equal, power will be consumed at capital R also at small r. We have total power, so that is E square upon R plus R whole square into R plus, that is R whole square, because small r is equals to capital R. We can write it Pi will be equals to, and that is E square upon 4R, R plus R cancel, that is E square by 2R. At the power input we can easily find the eta, so eta will be equals to efficiency PO upon Pi, that will be 1 by 2, or percent efficiency 1 by 2 into 100, that is how much? 50% efficient. Efficiency is 50%. This was the question 12th. Now this was the last question. Now next part 5th will be from heat. Also from heat there will be important questions. Now okay.